A BTU meter is a device that measures how much heat is transferred in a cooling or heating system. We can see this device in a HU. This device is mostly used in commercial buildings. If there are 5 companies in a building, the BTU meter is used to calculate the energy consumption of each company separately. Now let's know how this BTU meter works. First, let's see the formula used in BTU meter. Load equals flow rate multiply delta T divided by 24. Flow rate is how much water goes through the pipeline in 1 minute. We should measure this in gallons per minute. To measure this, a flow meter is installed in the pipeline, and it is connected to the BTU meter. So, we can know how much water is going in pipeline in BTU meter. Delta T is the difference between the temperature of the water in the return line and the temperature of the water in the supply line of the AHU. We should measure this in degree Fahrenheit. To measure this, temperature sensor is installed in both pipelines, and it is connected to BTU meter. So, we can know the water temperature in BTU meter. Now, let's take 2 offices, namely Office 1 and Office 2. Office 1 has full employees and Office 2 has very few employees. Now let's know how much billing is coming to both offices through BTU meter. As there are many employees in Office 1, a lot of heat will be generated there. Chilled water takes all that heat, so the temperature of chilled water increases. For example, chilled water enters the AHU at 6 degrees Celsius or 42.8 degrees Fahrenheit and exits at 12 degrees Celsius or 53.6 degrees Fahrenheit, as it takes a lot of heat from the room. Flow meter sensor measures how much water is flowing in the pipeline. Let's take this as 300 gallons per minute. Delta T is the temperature difference between the water in the return and supply lines. So, return temperature 53.6 degrees Fahrenheit minus supply temperature 42.8 degrees Fahrenheit equals 10.8 degrees Fahrenheit. Now, let's use these values in formula. Load is equal to flow rate 300 gallons per minute multiply delta T 10.8 degrees Fahrenheit divided by 24 is equal to 135 tons. When we multiply this value with 3.51, we get the kilowatt hour value. 135 multiply 3.51 is equal to 473.85 kilowatt hour. We will note this value from the BTU meter and give it as billing to Office 1. Now let's calculate how much billing is coming for Office 2. Since there are very few employees in Office 2, much heat is not produced there. So, the chilled water entering the AHU at 6 degrees Celsius or 42.8 degrees Fahrenheit comes out at 9 degrees Celsius or 48.2 degrees Fahrenheit. Let's use these values in the formula. Load is equal to flow rate 300 gallons per minute multiply delta T 48.2 degrees Fahrenheit minus 42.8 degrees Fahrenheit is equal to 5.4 degrees Fahrenheit divided by 24 is equal to 67.5 tons. When we multiply this value by 3.51, we get 236.92 kilowatt hour value in BTU meter. We will give this billing to Office 2. If there is any problem with the water flow sensor or temperature sensor, the reading may show incorrectly in the BTU meter. So, check these sensors if you have any doubts about billing. If water flow rate is 500 gallons per minute, supply temperature is 7 degrees Celsius, and return temperature is 11 degrees Celsius, then calculate the kilowatt hour value and tell in the comments section. This is how BTU meter works. If you have any doubts about the video, ask in the comments section. If the video is useful, then like the video and share this video if anyone finds this video useful. And subscribe to our Zebra Learnings channel. Thank you.